Hey, how's it going, guys? So this is Ben from Python BACnet Stacks Playground. This is like majority of my fun work. I enjoy kind of prototyping and kind of using AI to like really, if you have some ideas in mind, just to see if they're feasible, and you can do that like really, really fast. And I think it's getting faster and faster, which is kind of scary. But let me show you a little bit about what I mean by that. So this last three-part blog series, I did this in like 3 weeks, just kind of playing around with different AI approaches. So I was using like Cursor AI to crank out the Python code to do a lot of data science, a lot of data cleaning. All of the data was downloaded from a building automation system, and then we made a machine learning model. Then I was curious if to see if it can be brought into a gray box model, which is using some. There's tons of research on this too, so you can use AI to pull different research ideas, research reports. So that would be like I'm no expert at this, but so it would be like combining real data with physics, like a statistical representation of physics data, which can be from EnergyPlus physics engine, and you kind of mash that together with the actual data, where you can create a gray box model. So it's like statistical representation of the physics model, combine it with real actual data for the HVAC system, recovery rates, or fuel use. And then there's like, it's not quite a machine learning model, which is all black box and statistic driven, but it's actually gray box. It's combining um, the statistical representation of a physics model with the actual black box information. And so I was kind of like playing around with that and just learn a little bit more about it. And it kind of led down the trail of why not play around with reinforcement learning? And then the results were kind of so. And then this grid search idea, which was just a benchmarking basically. It was so I had this idea of like um, seeing if an AI agent or there was some brute force iterative um, computer science algorithm that could loop through different amounts of data and see if we could just come up with just the best optimizing for costs. Let me just kind of go through this a little bit. Um, so yeah, this broader research question, to me, I think like I was saying, just to prototype the stuff, I was like 3 weeks to do clean the data, do some modeling, and then kind of see what works best, and then even do like some kind of a BACnet application, which I want to do today. Um, but 3 weeks, like wow, that is 10 times faster than I think I could prototype in the past. I think I could blog maybe once a month just because it would take so long to do this, on the side, all by hand. But with this generative AI stuff, I think I improved my prototyping by 10x, order of magnitude. Um, and I think it can get even a whole another, I think it could go 100x. Um, so this is just, so I just wrote this yesterday, and I am super impressed at the moment with ChatGPT. I really like Cursor. I'll probably never go away from Cursor, just because it's been working for me. Um, and it's a fork of VS Code, so it kind of has this look and feel that's still familiar to me. That I think that's why I like Cursor, is because it's a fork of what I was used to before. Um, and then ChatGPT has this at GitHub plugin. I don't know how long this has been around, but this is cool. So like I can authenticate my GitHub uh, with ChatGPT, and it forked the repo. For one thing, I'm still interested in playing around with grid search. Like basically, the nuts and bolts of this is that grid search is kind of cool. So um, I'm gonna go over this really fast. Of course, the GIFs didn't render in here. But basically, I used AI to kind of come up with this reward policy that represents a human paycheck kind of a concept. So, like, basically, if you get $100 base check. Let's say you have to pretend that you were a building operator and you got paid exclusively if the building was at temperature for school. You could get $100 for that. And the easiest thing you could do is you just run HVAC 24/7. You never shut it off. Um, but then you can gamble. And for every kWh and kW that you can save, I was equating that to approximately 7 cents or something like that, 5 cents, even though their demand charges are like $12 a kW. Um, so it's just there's some like really weird math calculation that you can gamble. So you play with the building automation schedules, which we talked about this. Um, so it is like the concept is that you roll the dice once at midnight, look at the weather forecast, and then you guess where you want to start the equipment at 6 a.m., 3 a.m., 5 a.m., 24/7. So you roll the dice once is basically how this works, and then you gamble. If you save electrical energy, that's when you get your cut. You're basically how you make your money. You gamble. Um, and I was seeing if the AI could figure out the most cost optimized way of running the control system, basically. So, so this was grid search. Grid search would basically, if Energy Plus is installed in the edge environment, you could have a calibrated model on the IoT edge. You'd be running in Linux, um, and it would iterate over the Energy Plus model hundreds of times. And that would be ingesting weather forecasts, energy prices, iterating on this calibrated model, running a reward policy, and then we would set the building automation schedule, and then we just wait the entire day, and then do it all over again tomorrow, and then we factor in that reward policy. So that was grid search, and I could get the best results doing this versus reinforcement learning. Of course, there wasn't a ton of time put into this either, but so basically, um, so like it'd be like 2,000 Energy Plus iteration simulations ran. The idea would be you'd run all that once at midnight, um, which I don't think it's like that um, computationally expensive. Like, I want to demo this on this crappy old desktop computer with only 8 gigs of RAM. Um, Still has a Windows 7 sticker on it. That's just my little server that was, rather than recycling it, I just kind of keep it for like a play little Linux server that's about the same compute as a really old Raspberry Pi. Um, so I think even something like that could run it. And like when you only have to like run these simulations once at midnight, even if it takes an hour and it goes from midnight to 1 or 2 in the morning to run all those computations, and school doesn't start until 7 a.m., who cares if it takes a little while? It's cheap computers, cheap computing. Um, it's not doing, I want to get into this too at some point in time. Is like if you're doing, I want to experiment more in the future with reinforcement learning on a chiller plant, which I think is a good fit for reinforcement learning, where you would be doing expensive, heavy compute every 5 minutes, optimizing for kilowatt per ton. You'd be playing around with pumping speeds and chiller tower staging and pump speeds, fan speeds, that type of thing. That scenario, you probably would want it running every 5 minutes, 10 minutes, or whatever. and then there would be like a machine learning process getting done in between every 5 and 10 minutes, which would be, you would need really expensive hardware computers to do that. But I think just running this stuff once a day at midnight, roll the dice, set the building automation schedules and set points, and then you wait until the next day, do it all over again. So grid search was this computer. I iterate over and over and over and over until we find the optimized solution. It's like a brute force for looping kind of a application. So maybe like tomorrow we can. I have like just some scripts that just kind of mimic it. Like I think it'd be really good just to study like a little bit and what it looks like in more in detail. But it's just like nested for looping for this and then nested for looping this. Keep for looping through these different optimization strategies with this same the same paycheck. Um, Same thing that the reinforcement learning agent uses to know if it needs to when it's model training. We use the same thing in grid search as well. So like in reinforcement learning for Vibe Code 22, um, the heavy reinforcement learning training where I tested PPO, which is a reinforcement learning algorithm, and then deep Q learning networks. These guys ran about 24, I think they ran for a day overnight. So heavy compute, they were iterating over the EnergyPlus model, trying to learn it, figure it out. And then each time, and then basically what you could do after that, after it runs for some good enough amount of time that it gets half accurate, then you would serialize that model and bring it to the IoT edge where you do the same thing again. You'd be gambling, except this would be no EnergyPlus is needed. Basically, if reinforcement learning was running on the edge here, you wouldn't be on the Linux edge having EnergyPlus installed there because that was pre-trained here. You'd be pre-training on the real data. But I couldn't produce the best results with reinforcement learning here. So maybe grid search is just a better application. I don't know. For this iterative process of finding the most optimized algorithm. Um, but this was pretty fun. So let me just get down to my final results. Maybe I can zoom in here. So this is just a chart of the data. Um, Basically just playing around with the winter data because that's when they were pinged. Is that what I wanted to do is if you run the building 24/7, you wouldn't have large spikes in electrical energy because this is an all electric building. Um, Coldest Monday morning, which we were kind of optimizing for, is when they peak their demand. A really cold building starts up, requires this enormous amount of electrical energy to heat it up. So they peak in the coldest day in the morning, which is kind of opposite of peaking in the air conditioning at the hottest point in the afternoon in the summer. So that's what I wanted to do was basically see if the algorithms could figure out if running the building 24/7 was more cost effective during cold weather. So we even did some grid search where if the outside air temperature is below 10 degrees, maybe I'll just actually go back to one of these articles because I think it kind of. So I'm just going to go back to my posts. To make a long story short, is like I could not beat what they were doing. Okay, so if I go down here, so this is basically the electrical data right here. So looked at this a little bit before. See if I can zoom in or not. So this was the school coldest morning. I think it was 10 below zero overnight in degrees Fahrenheit. They peak at 300 kW right when it starts up. And then what in this mild weather band right here, that is lowest amount of electrical energy, lowest amount of electrical power required. And then I was almost kind of curious to see, like, at some magical moment in time below 10, 20 degrees Fahrenheit or 30 degrees Fahrenheit or 10 is when you would just run the building 24/7. Um, and then the idea would be is like you'd shave off these startup events. So 100, if you got your demand down from 285 to 200, you could run the math, economics on what would that save you in your demand penalty all year round. And for some buildings, that could be a big chunk of change. So this building in particular, um, the demand, this area of the United States, it's just the costs for electrical power from your utility rates. It's just not that economically very good. So if you are in California where you have like $20 per kW, or New York City or something like that, maybe there would be a better solution, but I could not beat that. So let's see, where were we? Okay, so like on this chart here, the actual utility usage was 100 150,000 kWh, 284 kW. And then this is with the building automation system having an optimal start algorithm. And you can kind of see that in here. Like the building started at about 3 a.m. Optimal start algorithm ran, and then school probably started around here. So this electrical usage right here was from optimal start, warming up the building, and then plug loads and people pushed it up over 300 is what the submetering measured. So they do something with optimal start. They must have like a really decent optimal start algorithm, because they do run the buildings efficiently from a kWh perspective, like when they reduce the equipment runtime as least as possible. You need a really good optimal start algorithm for that. And it can be really hard to tune these and get them working right. So like when the weather is mild in this band, weather range, from 40 to 60 degrees Fahrenheit, 60 plus, you can kind of see it in the data. That is when if your optimal start algorithm is working properly, it would be just bare minimum run hours for that HVAC of when school starts, when school stops, and nothing on the weekends unless there's some kind of event or after hours. So bare minimum run hours. And then as the weather gets colder, the optimal start algorithm just decreases at startup times as needed. So they must have a really good optimal start algorithm. And myself trying to use artificial intelligence to replicate that, which also factors in not only having the space is warmed up to temperature in time, it also factors in optimizing for costs, both in electrical energy in kWh and kW. So like this optimal start algorithm does not care about utility bills, electrical power, or electrical energy charges. It doesn't even have that as a feature into the input of the algorithm. It only cares about if space temperatures were warmed up by the time school starts, and it doesn't care about demand charges or anything. So what we were doing with 5app22 was it cared about both. This algorithm, grid search, and reinforcement learning factored in not only was it up to temperature, but it also was optimizing on the costs for the KW and KWH, which is kind of on this axis right here. So like the actual utility and then my best energy, so this is the actual utility usage and the best EnergyPlus model that I was training to meet guideline 14. This is the equivalent. So basically, the way that they operate the building with this pretty decent optimal start algorithm, they were sitting at about 150,000 kWh per year, peaking at 284, and with the actual utility bills around $15,000 for this relatively small elementary school. And then the best version of that in EnergyPlus, which is a little bit different because this might be not a apples to apples representation. Might be just like a little bit off in like the way that the calendar year works in EnergyPlus and actual utility bills. But my best model that was guideline 14 was 155,000 kWh, 287 kW. So they both peaked, and then about $16,000 in my calculated utility usage. So pretty close. This is like one part of the model. Guideline 14 dials in the KWH. And then I also had to tweak it again to dial in electrical KW while still maintaining guideline 14. And then these actual utility bills are pretty close. That's the best I could do. And then what I wanted the artificial intelligence to do, including grid search, was to, I should have kept that other window open, but it was to increase the runtime with the idea of you lower demand. So like when you increase the runtime, even run the building 24/7, which is a really common practice in building operations, is to run buildings 24/7, which I think people do too much. Like they're kind of scared of it. They do it for temperature complaints, but what I wanted to do it for was to reduce demand charges. So if you run the building 24/7, the building never goes cold and it never has that big peaking moment when everything starts up. So, and you can kind of see that, and when we simulated that in EnergyPlus, running the building continuously, though the model KW only drops down to 40 kW difference, which I kind of find hard to believe. I think I had one model that got all the way down to 208 kW. So when you run the building continuously, your demand charges drop, but your electrical energy usage increases. And you can kind of see that in here. And then what I'm optimizing for is actually to do a little bit of both. So like there's not much of a difference in here actually. So like when I optimize for the differences, there's only like less than $1,000 difference between the grid search optimization process of it's iterating over all these different scenarios. So basically in here, the AI agent has the ability, it'll roll the dice, run 24/7, do a series of setbacks. So 60-minute pre-start, 180-minute pre-start, even longer than that. And then it also has the ability to experiment with different setback zone temperature set points. And I iterate over and over and over with an EnergyPlus model, a calibrated one, and you can kind of come up with the most optimized way to start the building, still meet zone temperature set point with the most optimized cost for that day based on the actual utility rate tariff. So that was the idea behind this science experiment. But what I was coming up with was I can't beat, what they're doing. So I think like the I can reduce the demand, um, and then I increase the kilowatt hours. Uh, so I can reduce the demand charges, and but I increase the kilowatt hours. Um, so that's kind of like where it where the mayonnaise meets the mustard, I guess. So like, um, I think like what this kind of could be best fit for is if you had like really complicated rate structure. Let's say your rate structure is time of use rates for electrical, if it's changing hourly. Some places in the US and Canada and Australia, Europe, you could live in a place where their electrical energy use rates are constantly changing. So sometimes there's even an API for that, where like Open Weather Map API, like where we can grab hourly weather data, what it'll be in the next 24 hours. We can also grab from the utility provider what are the next 24-hour time of use rates. And then this is where I want to go into experimentation again with grid search, where you would get the next 24 hours data, and let's roll that dice on this is our weather, this is our rates per hour. Let's I iterate on this calibrated EnergyPlus model. Keep on iterating over and over. Um, so that's where we're gonna go with the next Vibe 23. I have that. And what I was telling you earlier is like with ChatGPT, with these GitHub um, GitHub plugin. I just authenticated with I've been doing this last all weekend actually. Is I've been really impressed with ChatGPT lately. Um, I can finally maintain all of my code bases from my phone. So like I think this has been around for probably a couple months. I might be a little late to this bandwagon, but I'm just so used to local development. Um, Traditional, you always code on your computer and you push to GitHub, let it run, do its thing up there, pull, push. And um, this is slick. So another thing too is like I'm so used to um, like operations technology, building automation systems, BACnet. It's like you have to be interacting with something locally. It doesn't, with a BACnet device, so you have to run stuff locally. But you can like these. Cursor has some cloud tool, I think. I'm sure Claude does. So if you're just making a web app or running some crazy mad scientist experiments, you can just do this all on their cloud thing. Okay, so this is like, and I think like this will become like an order of magnitude faster. Like these ideas of prototyping, like I was saying, this would have taken me 4 months to do Vibe Code 22. I bet. I bet that 3 to 4 months, and I did that in 3 weeks. So that's an order of magnitude shorter, um, 10x, and then I think I can even 10x this. So I'm shooting for 100x faster all through this. So like what's going on here? So this is going to be Vibe Code 23, and I just from my phone I found LBNL building research system. I found a building. Um, Wanted to play around a little bit more with uh, using AI to calibrate an EnergyPlus model. Um, and then some more of this demand flexibility, grid search, experimentation. So like just with like Google and ChatGPT, they recommended because I wanted to I need a building, I need a data set, fuel use, and then a place in the United States or where in the world where demand prices are really high because this Wisconsin school, I I've heard this before too, is that the Midwest USA is just the demand cost for demand prices. It's just not there to be installing battery systems or doing much in demand side management. But go to California, New York City, Ontario, all these other places, Australia. It is, the economics are there. So like, I want to play around with grid search a little bit more and see if we can do this. So basically, I had wow, there's a massive data set, 174 gigabytes of data. Um, so basically, LBNL. This is Lawrence Berkeley National Lab. So in San Francisco area, Berkeley, LBNL. This is where a lot of research gets done. So they have like a data set we can play with, and high demand areas. So okay, so like this is the next data set we'll play with for Vibe Code app uh, 23, and it's hardly a Monday, and ChatGPT is already going nuts on calibrating a guideline 14 physics model just off of lessons learned from prior experimentation. So this is, to me, a whole nother order of magnitude even faster than what we've been doing. So like, I almost want to say like, it could get this down to instead of 3 weeks, a week. So instead of 4 months, get that down to a week, to pumping out some kind of like a concept idea, prototyping. Like it's getting so fast. Like I think this is like the age of 100x. Um, yeah, I can't go. If I can get this, um, okay. So best bounds case. Let's see what January September is roughly. So it's not very good model at the moment. Way outside of guideline 14. Like these numbers have to be within 15 and 5% for the guideline 13 net mean bias estimator and this RSME root mean squared error number, still way outside. Which still, ooh, okay, so it's still running. And like another thing that we're doing, I'm just gonna go to here. It's like, um, is I have done a. It's supposed to be building like a. Looks like it's not pushed in, so it's like it needs to be pushed. The code needs to be pushed to GitHub, but there is a this skills. So these are AI agent skills in these Vibe Code apps, and I am part of here the Python BACnet playground. There'll be a joint skills. Like I need to start um, compiling this all into one agent skills file thing. So like all these lessons learned, because there's some things that ChatGPT isn't trained on, and then you are figuring out how you do things. So that's what you use the AI agent skills for. It's has to make a note on how you like things done. And there's a couple of things that we just don't know. Okay, so we have the building 59. This will be Vibe Code app 23 to play around more with. So if we could do a calibrated model of the HVAC systems and then make sure that it's a relatively detailed model too, like if we can get component levels of the HVAC systems, like air handling unit levels, set points, chiller plants, pumps, fans. If we can start playing around those set points, that is when we get the good stuff for demand side management. And what would be really fun to play around with too is if you could do battery systems, building energy storage, the best. Um, well, so building 59 is a medium office with two office floors, one mechanical equipment, and the other floor is data and computing. The data set only covers two office floors. The building management system monitors archives high electrical usage, HVAC and lighting, indoor conditions, on-site weather. Wow, so we get on-site weather and occupant counts and Wi-Fi connected devices. This data supports multiple use cases such as model predictive control and occupant related demand management. Huh. Oh, it even has that in there. (2018 to 2021). So I don't know. Maybe like this building they've already done. Okay, so it's 4 rooftop units with VAV boxes. Nice to know. Berkeley, California, 100,000 square foot plus, built in 2015. So that's a large size office. I thought anything over 100,000 square foot would be more, this number would be more a large office, but guess not. Um, so this will be fun to play around with. So this will be Vibe Code app 23, and my goal is just to see if this stuff can get done faster and faster. I thought it would be okay. So look, they're already getting better. So like, um, this needs to be below 5. A restart safety check and then caught a couple of coil edge case for blah blah blah. So it's like still trying to meet guideline 14, and will still the neat thing is though is like in this little sandbox where ChatGPT runs, it installed EnergyPlus. So it's just running its own EnergyPlus version wherever the heck it's running. Um, and it can pull my code and refactor it. And then I can, on the go, I can be, asking Soul Max, are you done yet? Are you done yet? Keep going. What, why not? Why not? Why not? Go, go, go. Change this, change this, change this. And update the skills, update the skills. So, and this is neat. This is awesome. This is what I was looking for, is like some neat tool that I can do from the go on my mobile, and stuff is going to get faster. I was hoping that it would be um, so to check this out. So make sure you know my browser is going really slow. Using the best methods for modeling, the the data of the building, the data set, including occupant loads, HVAC runtimes, as well as analytics from the HVAC systems, set points. Actual data analytics should be used for set points. Say the link says this. Probably knows all this already. Make sure represents hash rate 90.1 energy code requirements of 2015 and good model of billing based on actual data. Revise plan as needed, if needed, if modeling efforts were far off. Okay, so it's gonna, this is basically what I've learned and put in the skills is like sometimes working with ChatGPT on refining the EnergyPlus IDF model. Cool. I think I've covered everything I want to cover in this video, and then sorry, I didn't even get to this, but like now I'm going to switch to Codex. This is ChatGPT running locally. And I have 1% left of my cursor usage until it renews in a week, fortunately. So I want to see if I can crank out. So Vibe Code App 22 was supposed to contain a concept idea of the BACnet application, and maybe we'll do that tomorrow. So I have a prompt through here. It's prompted. I just have to see if within 1% we can do this in as well. So so this is a prompt made by Codex, and basically it's supposed to mimic what it would look like if Vibe Code App 22 had a BACnet application, which we'll do in the Rusty BACnet stack with Python bindings. So we'll just kind of play around with prototyping a BACnet application. Hopefully it'll just make more sense too. So like the RL agent or grid search they'll gamble when they want the HVAC system to start. So they do the gambling once at midnight, and then we have a schedule for the building basically. And then we'll use that schedule to kind of manipulate BACnet points to turn true or false, on or off, based on the current computer time. It's actually really similar to demand response, like OpenADR. In demand response, a server pushes a payload to the edge or the building of demand response event, start time, end time, and the only thing the edge device does is just sits and waits. So it just waits until current time is greater than or equal to OpenADR event start. If it is, then it conducts whatever it needs to conduct, and then it turns off when it's supposed to turn off. So we're kind of like in the BACnet application prototype is like to mimic open automated demand response. So that's it's not like it's pretty simple actually. There's not much to it. So like the AI rolls the dice. When does the HVAC system start? And then the BACnet application just sits and waits, wait until these different zones were supposed to start. So like this is actually just a massive prompt that I think is like way overcomplicated. And I'm just really curious to see um, if my 1% of cursor usage that I've left this month can do this within 1%. But hey, I've seen crazier things, and let's dive into this tomorrow. So this will be tomorrow's YouTube video. Please ping me on Discord or through LinkedIn if you have any questions, or there could be a lot of different things that I'm missing the mark on. I'm really interested in this too. This is all like very exploratory, to be using EnergyPlus calibrated model. Um, so it's fun. I think like people should be doing this stuff. This is the age of 100x on pumping out stuff. That's just like so many existing buildings out there. So like let's start optimizing. All right, guys, we'll talk to you tomorrow.